Lecture 6 summary video. So the first thing that we talked about is going to be the hydrogen emission spectrum. And we talked about this in lecture 5, but the main thing that we hit on in lecture 6 is going to be the relation between these two images. So as we're looking at this one up here, the first thing that we're going to notice is that we have photons of light, this should be for hydrogen, coming down from bigger sub levels and energy levels down to a specific level. So for the Lyman series, it's going to be the ground level, the first level. And then for the Balmer series, it's going to be your visible light. It's going to come down and it's going to hit sublevel 2. And then for your Paxton series, it's going to come down from infinity shells and hit number 3. And the main relation between these two images is going to be that there's going to be really big gaps from your higher energy levels, and it's going to get infinitely small as you get down to the level that they're going to hit and stay at, that the electrons are going to stay at. So for the Paxton series, it's going to get infinitely small to the third energy level, and then for the Balmer series, it's going to get smaller and smaller until it hits level 2. So the different orbitals that the electrons are coming to are going to come down and then hit a different orbital. And then we can see those orbitals in this diagram. So what's cool about this one is it's going to show us the probability of where we're going to find the electrons. So for this one, for example, it's really, really bright in the middle, and then it's going to have almost like a ring of where you're not going to find any electrons, and then it kind of dissipates outwards. So it's just showing you the probability of where you're going to find the electrons. All right, and then your quantum number. So our first important quantum number is going to be your principal quantum number, characterized as n, and what n really means is the number of the sublevel. So if you're talking about 1s2, 2s2, it's going to be the first number in that sequence. And then for your angular momentum, it's going to be the letter of the orbital. So it'll be the p orbital, or it will be the d orbital. And then for your magnetic quantum number, it's going to tell you which iteration of your letter orbitals that the electrons are found in. And then the spin quantum number, it's just telling you which way the electrons are spinning, whether they're going to spin clockwise or counterclockwise in their specific orbital. And those principles are supported by the Pauli exclusion principle, which states that each electron has a specific number of quantum numbers, and it's going to tell you exactly which electron you're looking at in your electron configuration that you are given. And the main way to go between these, this is an example from class. So your n is going to be your number of your sublevel, right? So if you're given 3, it's going to be a 3 in front. So you're looking at your third sublevel for whatever letter orbital you're given. And then same thing here. It's going to be a 2, so you're looking at the second s subshell is where the electron is going to be. And then your M1 is going to be which of these orbitals up here it's going to be in. Oops. Okay, so for the d orbital, there's 5 different possibilities. And for your s orbital, there's only one possibility. So your number of orbitals is really your number of possibilities of where that electron could be. And then Hund's rule kind of just says that the electrons are going to fill all of the orbitals once before they put a second electron in each orbital. So if you look at this diagram over here, this one is full. This is going to be your zinc element. It's going to be number 30. But what it's saying is it's going to fill this one, and then it's going to fill this one. And then when you get to your levels that have more than one orbital option, it's going to fill this one and this one and this one first, and then it's going to go back and fill from numbers 4, 5, and 6. So the numbers really go 1, 2, 3, and then 4, 5, and 6. So it's going to fill all of the orbitals once before it goes back and adds another one. And then the last thing that we touched on is going to be the magnetic properties of electrons. We've talked about how they act as waves in past lectures, but this one we kind of focused on more of the magnetic properties. That has to do with that clockwise or counterclockwise spin of the electrons. So basically the paramagnetic substances are going to be when they have the unpaired electrons, like when your orbital looks like this and you only have one electron in it. If you come look at this up here, it's going to be when you only have one electron in that little orbital. And then your diamagnetic substances is going to be when you have two in your orbital and it's a full orbital. And it's just saying that most substances are bonded to other substances. So these magnetic properties are going to change as you add more compounds and more atoms and different things together as they're bonding and going through chemical and physical reactions.